In this video, we're going to be going over the production of sulfuric acid, and we're going to look at all the detailed steps inside of this production, and we're also going to look at some safety concerns as well. And this is our part 8 video inside of chemistry, chapter 3. So let's get started with this video. So starting off, we're going to talk about the process diagram and the different steps that sulfuric acid is created by. So if we look here, there's the 4 different steps. Step 1 is right here, where the sulfur burner is. Step number 2 is over here, where it gets converted inside of a catalytic converter. And then step number 3 is over here, once it reacts with a different substance. And step number 4 is here, once it actually becomes the H2SO4, which is sulfuric acid. So in this case, we're just visually depicting each step of the process from burning of sulfur, which is up here, all the way to the final production of sulfuric acid. So now we're going to go over each step and see what happens inside of each of these steps. So starting off with step number 1, which is sulfur burning. So here we can see, first of all, we have to actually put the sulfur inside of the melter. So it goes into the melter and then it comes over here to step number 1. So in step number 1, sulfur is burned to produce sulfur dioxide. So here, once we've melted the sulfur, it'll come until here. And then we have oxygen also getting here. So once we combine oxygen and sulfur, then it produces sulfur dioxide. So basically we have sulfur from up here, and then plus oxygen. Once those two combine, we get sulfur dioxide, as we can see right here. In this tunnel right here is where all the sulfur dioxide contained. So basically inside of this container right here, solid sulfur is combusted in the presence of oxygen to form sulfur dioxide gas. And as we said, this is the tunnel where all the sulfur dioxide gas stays. For step number 2, this is where we actually create sulfur trioxide. So sulfur dioxide from this tunnel is then oxidized to sulfur trioxide in the presence of a catalyst, typically vanadium oxide. So in this case, over here, vanadium oxide is inside of here, and this is also a catalyst which basically converts this SO2, which is sulfur dioxide, into sulfur trioxide. So from this tunnel we have sulfur dioxide, and once it escapes and goes through this catalyst, then it'll become sulfur trioxide. And basically here we have sulfur dioxide plus more oxygen is equal to sulfur trioxide. So 2 molecules of sulfur dioxide gas react with 1 molecule of oxygen gas to form 2 molecules of sulfur trioxide gas. And this reaction is exothermic and reversible, as it is conducted inside of a catalytic converter at a temperature about 450 degrees Celsius. For step number 3, this is where we convert everything to oleum. So sulfur trioxide is then absorbed in the concentration of sulfuric acid to produce oleum. So in this case, sulfur trioxide goes into here, and then what happens is that since this is the solution, all this goes down and then it comes up through here, and it basically just mixes. So if we look here, we have sulfur trioxide plus sulfuric acid, but it's a low concentration. So we have this sulfuric acid coming up here, and then we have the sulfur trioxide. So once those two combine, we're going to get a product of oleum, or high phosphoric acid. So basically here, sulfur trioxide gas reacts with liquid sulfuric acid to form liquid oleum. And this process allows for easier and safer handling of sulfur trioxide, since it is absorbed directly into the acid rather than being released. And just a reminder, here we have sulfur trioxide, and then we're taking a low concentration of sulfuric acid. So over here, this would be a high concentration of it, but up here, it's a low concentration that's getting mixed with this sulfur trioxide in order to form oleum. And for step number 4, here is a formation of sulfuric acid. So oleum is then carefully diluted with water to produce sulfuric acid as a desired concentration. So here we can see once the sulfuric acid and also sulfur trioxide react, and after we get oleum, this oleum gets diluted into this water and mixed with the water, and then that's how we can actually get sulfuric acid. So the formula for this is basically oleum plus water is equal to sulfuric acid. So liquid oleum in this case reacts with water to form more sulfuric acid, and this step must be controlled carefully to prevent violent reactions due to the highly exothermic nature of the dissolution process. So in this case, there also has to be really good safe handling because this has a really high exothermic nature. So now we're going to talk about the safety and also environmental concerns of the production of this sulfuric acid. So throughout the process, there are stringent safety and also environmental controls due to the toxic nature of sulfur dioxide and also sulfur trioxide. So both of these gases are very toxic. So that's why there's a lot of concerns about safety and also the environment. And also there's some more safety concerns of the corrosive properties of sulfuric acid and also oleum. So this process of creating the sulfuric acid is designed to minimize emissions, and any waste gases are scrubbed to remove pollutants before being released into the atmosphere. So inside of the contact process, sulfur dioxide and sulfur trioxide are converted into sulfuric acid, so they do not remain as waste products. So all of the sulfur dioxide and trioxide, they're not waste products, and they're all converted into something else. And then in this case, oleum reacts with water to form sulfuric acid, which is the desired product. So in this case, oleum is also not being used for any harm, and therefore all these substances are not disposed as waste, but instead they're transformed as valuable products. So that summarizes everything for the formation of this solution, which is sulfuric acid. So thank you so much for watching. Try to be useful, and we'll see you in our next chemistry video.